My problem is about congestion of people in banks. By the way, good evening. My name is Mutumba Robert. Many people visit banks on daily basis with different reasons and purposes. Mainly, some of them visit to deposit, withdraw, and others receive loans. Although people go there, but they face a lot of problems like congestion in banks, which make them to spend a lot of time in banks while waiting to be worked upon. Even some of them, they aren't worked upon on a particular day, they just come back later. So the congestion problem is mainly caused by poor management of banks regarding to time and even labor. So how artificial intelligence is applied to solve the above problem by using general type of AI, whereby machines can do same activities which humans can, and even machine learning which can handle data in order to solve complex problems like congestion of people in banks. I will create a tailored customer scheduling machine. This system will enable customers to perform and complete their tasks in banks without congestion, whereby a customer just comes in the bank, fills in his details on the laptop and the reason why he is in the bank. If it is depositing, just fills in there, prints out a form containing a token number. Then it is that token number which will the system call, and the customer will just go to the teller the system has directed him to go. So this means that the customer will just print out a form, sit somewhere, and wait to be called by the system. So what type of data did I use? There are a lot of data, but for me, I decided to use secondary data since the data of my program already exists on staging websites like Cargo. So the Cargo acts as a sensor of data needed from the environment into an action by actuators in order to complete agent program. There are differences like between supervised and unsupervised learning, whereby models in supervised learning are trained using labeled data, and models in unsupervised learning are trained using unlabeled data. Whereby models predict output in supervised learning, models find the hidden patterns in unsupervised learning. Models produces accurate results in supervised learning. Models produces accurate results in unsupervised learning. Models take direct feedback to check if it is predicting correctly or not, while in unsupervised learning, models don't take any feedback. What is a model? A model simply is a device which can use data algorithms in machine learning. So supervised learning techniques, there are a lot of supervised learning techniques, but for me I consider two. First one is decision tree, where the congestion of people in banks is mainly caused by poor management system. This thing is the act of decision making in the above sector, but decision tree is easy to understand and implement. So decision making will be achieved since decision tree is easy to understand and implement. So this technique is easy. So we have linear regression, whereby it alerts the workers in the bank about the financial predictions which will be faced by the bank. For linear regression, it just predicts for the future. This prediction information is handled by the workers and spread to their customers via the website, sending SMS on their phones. This activity will reduce congestion since customers are informed early about what will happen. So we have unsupervised learning techniques like clustering rules. This technique will mainly group customers who have similar reasons of being in the bank. Like they are a group of customers, they want to deposit money, so they will be there and they will be given a tailor who will solve their problem, their issues, and this will save time and reduce on the congestion of people in the bank. So we have association rules. The grouping of customers in casting rule will enable the workers to extract customers' data using association rule. The workers in the bank will be capable of knowing their customers' desires and interests. This will improve decision making, which will perfect the management system and reduce congestion of people in the bank. So we have technical challenges. First thing is limited knowledge. So many workers fear these software machines or AI systems. So the teller customer scheduling system will be used to reduce on the number of customers in the banks. This may require to be upgraded manually, and due to the limited knowledge among workers, this problem will result into increased congestion. You have data scarcity. The data scarcity will increase the congestion of people in the banks, since the workers will take a lot of time while looking for the data of their customers. You have limited technical requirements in the banks. For example, the scarcity of computers which store customers' records. This will cause congestion, since the demand of customers' interest to overtake the quantity of requirements used. My slide 8 is solutions of technical challenges. Training workers about the customer scheduling system. This will be used in the bank, so we will teach the workers about the functionality of the system. The second one is employing expert workers, for example, data administrators, which this will reduce on the rate of data loss in banks. So this is buying new technical requirements in the banks, for example, computer. This is easy and everyone understands it. So differences, right now there is differences between accuracy, recall, precision, if one score, whereby accuracy is the ratio of correctly predicted observations to the total observations, ratio of correctly predicted positive observations to all observations in actual class. Precisions, ratio of correctly predicted positive observations to the total predicted positive observations, where F1 score weighted average of precisions and recall. My slide 10 is AI evaluation metrics, whereby A under the curve is my first one. I considered it because it's mostly widely used metric, since it is known by many developers and even it's easy to learn and implement. It is also used by binary classification program. A under the curve is equal to the probability that the classifier will rank a randomly chosen positive example higher than a randomly chosen negative example. The second one is called classification accuracy. It outputs satisfying results after evaluation. It has the word accuracy, which means the ratio of number of correct predictions to the total number of input samples. Since my project contains related data, the classification accuracy works well for data belonging in the same package. There are links which are used and references to collect this data, but due to limited time, allow me to stop here. Remember, Tomba Robert, and a big right if you subscribe to my YouTube account. Yeah, let the software engineers roll and let the projects run. So have a blessed day.